Let's learn about the structure and electrical characteristics of MLCC and the types of capacitors. MLCC, or multilayer ceramic capacitor, is an essential component in electrical and electronic products such as mobile phones, TVs, and automobiles due to its various roles in electronic products, such as controlling current supply and demand to ensure a stable flow of power current within the circuit, as well as its role in noise removal and filtering. It is expected that more than 1,000 MLCCs will be installed in smartphones and more than 10,000 electric vehicles will be installed. And it is expected that there will be continuous demand centered on the automotive electrical market in the future, since so many MLCCs are installed in each product. They are also called the rice of the electronics industry. MLCC package types include various packages of SMD standard size and array type that integrates multiple capacitors into one to secure mounting space in high-density devices such as mobile phones. MLCC consists of a ceramic material body, internal electrodes, and external electrodes, i.e., connection terminals. The internal structure is a form in which ceramic dielectrics and internal electrodes are alternately laminated, and the ceramic dielectric is laminated between the multi-layer internal electrodes to act as a capacitor that stores electricity. Recently, as MLCCs are increasingly used in areas such as electric vehicle electrical components, the technology to produce high-spec MLCCs that can operate stably even in extreme environments such as high and low temperatures, large impacts, and high humidity has become extremely important. The inside of the MLCC is made up of 500 to 600 layers of internal electrodes tightly stacked within a ceramic dielectric. MLCC is made by stacking these thin layers and baking them at a high temperature of over 1000 degrees without cracking. There is a very small capacitance between each electrode, and since the two connection terminals are equivalently connected in a parallel structure, the total equivalent capacitance is the sum of all the capacitances between each electrode. Therefore, as the number of layers increases and the area of the overlapping electrodes increases, the capacitance increases. An ideal capacitor would have only pure capacitance components, but MLCCs have a pure capacitor, C, as well as small resistance components R and inductance components L in their internal electrodes due to their internal physical structure. In this way, all conductors have small resistance and inductance components that are very small but correspond to parasitic elements. That is, since the internal electrodes laminated between ceramic dielectrics are conductors, there is a parasitic resistance R and a parasitic inductor L in one MLCC. These parasitic elements R and L have a parallel structure equal to the number of laminates. So the resistance converted into the parasitic resistance of all layers is called the equivalent series resistance, ESR. And the inductance converted parasitic inductance of all layers is called the equivalent series inductance, ESL. That is, in addition to the original capacitance C. An MLCC has unintended ESR and ESL. In general, designers only consider the pure capacitance value because ESR or ESL are very small values, but in high power or high frequency ranges. These parasitic components affect the operation of the circuit, so if they are not considered, the intended function may not be performed, resulting in unexpected results. The ESR of a typical MLCC is 10 milliohms or more, and the ESL is several nanohenries or less. The larger the MLCC size and the longer the internal electrode length, the larger the ESR and ESL. Looking at the change in impedance according to frequency due to ESR or ESL of MLCC. In the low frequency range, it acts as a normal capacitor with the impedance decreasing as the frequency increases. But as the frequency increases, at a certain frequency, The original capacitance C and the parasitic inductance ESL are in a series structure, causing series resonance and a short circuit, so only the parasitic resistance component, ESR, acts as impedance. The frequency at this point is called the self-resonant frequency, or SRF. SRF has the general LC series resonant frequency formula, that is, the relationship of 2 pi root LC, 1. When the self-resonant frequency, SRF, is exceeded, the original function of C disappears and the characteristic of parasitic inductance ESL, that is, the impedance increases as the frequency increases, takes on an unintended function. Therefore, this area has inductance characteristics rather than the role of a capacitor, and loses the noise bypass function. Therefore, a countermeasure for this is necessary. In other words, you need to apply a type with very low ESL, or apply 2 or 3 or more MLCCs in parallel to shift the self-resonant frequency SRF to a higher frequency range as much as possible, thereby expanding the frequency band of the capacitor's operating area. In the application of noise-removing capacitors, the reason for adding MLCCs with capacitances other than 0.1 microfarad and connecting them to the power pins of the IC is to upwardly shift this SRF. The classification of MLCC uses a 3-digit standard notation such as X5R, X7R, Y5V according to the range of capacitance capacity change according to temperature. The first digit indicates the lowest temperature, the second digit indicates the maximum temperature, and the third digit indicates the capacitance value deviation. The first digit X indicates -55 degrees, Y indicates -30 degrees, the second digit 5 indicates 85 degrees, and 7 indicates 125 degrees. The third digit R indicates a deviation of plus or minus 15%. And V indicates a deviation of -82% to plus 22%. This change in characteristics according to temperature varies depending on the applied dielectric material. MLCCs tend to have a capacitance value that decreases as the temperature increases, but the temperature-compensated C0G type is hardly affected by temperature changes. And X5R and X7R have a deviation characteristic of plus or minus 15%. In the case of the Y5V type, it is necessary to be careful because the fluctuation range is large, from -82% to plus 22%. Looking at the capacitance capacity change characteristics according to the applied DC voltage on the right, when the rated voltage of the MLCC is fully applied, the C0G type shows almost no change. But the X5R and X7R show a capacity decrease of less than 20%, and the Y5V shows a capacity decrease of more than 50%. Therefore, it can be seen that setting a margin of 20 to 30% for the applied DC voltage when applying MLCC can reduce the capacity decrease under actual operating conditions. Capacitors are one of the most commonly used passive components. In the application of these capacitors, the terms bypass capacitor, decoupling capacitor, and coupling capacitor are often used. Let's learn about the differences between these terms and how to apply them. Bypass refers to a capacitor that bypasses high-frequency noise components coming from the power supply or other circuits to ground, thereby allowing the IC to operate stably without being affected by noise. Decoupling literally means separation, and it refers to a capacitor used to block and isolate the noise in IC2 from affecting the power line of IC1. In other words, most power lines are commonly connected to multiple circuits or ICs, and this capacitor is used to isolate the noise between the power lines that are interconnected between these circuits. The decoupling capacitor not only suppresses noise going out, but also acts as a momentary current source to the IC, and plays a power stabilizing role by suppressing fluctuations in the power line. It is important to place this decoupling capacitor adjacent to the power pin of the IC. Coupling means connection. When the signal output from the IC source is an AC signal containing a certain DC component, it refers to the capacitor applied when only the DC component must be separated and only the AC signal must be sent to the next stage amplifier. In other words, it is a capacitor with the purpose of DC blocking and signal connection, and the capacity value can be determined according to the frequency of the AC signal. And generally a capacity of several microfarads or more is applied. Capacitors for bypass and decoupling purposes are often used interchangeably because their functions and effects are similar, and 0.1 microfarads are most commonly used in actual applications. Capacitors are classified into nonpolar and polar types, and in nonpolar types, they can be divided into ceramic capacitors and film capacitors. In addition, there are various types. And among ceramic types, MLCC is the most commonly applied. MLCCs are also classified into Class 1, which is temperature compensated, and Class 2, which has a high dielectric constant, depending on the ceramic material used in the dielectric. Class 2 is widely used due to its high capacitance characteristics. Even in Class 2, it is divided into X7R, X5R, Y5V, etc. According to the temperature range and capacitance deviation according to the EIA International Specification Standard, they are classified into electrolytic and tantalum capacitors based on polarity. Electrolytic capacitors use electrolytes, so their lifespan is relatively short due to leakage or loss. And their high-frequency characteristics and temperature stability are poor, but they have the advantage of being able to have a large capacity. Tantalum capacitors, which complement the shortcomings of electrolytic capacitors, have advantages in lifespan, temperature stability, and size. When comparing the characteristics of each type, the film type has the highest operating voltage, that is, the rated voltage, and the electrolytic type has the largest electrostatic capacity. MLCCs are suitable for decoupling for noise removal or signal coupling because they have excellent high-frequency characteristics. While electrolytic capacitors have the advantage of large capacitance, but their size is large and their lifespan may be an issue. Tantalum can be made into small, large capacity products compared to other capacitors, and compared to large capacity ceramic capacitors, its capacitance has high stability over voltage and temperature. Therefore, please remember that MLCC is suitable for signal processing or noise removal, and electrolytic or tantalum capacitors are suitable for large capacity capacitors required for power circuits. Thank you. Bye.